Yeah, I'm from Fentress, design technologist at Fentress. That's all I need to know about me for now, because I've not a lot of time. How many of you have as-built models that you get and you have to remodel the whole thing? Okay. So one way to deal with that is to access all the room data from that model and remake all those rooms in the other model automatically. I'm not going to share that today, but I'd be happy to share it. I was trying to be more practical because I don't know how practical this will be today. It's practical at Fentress. How many Rhino users do you have, or users at your office who might use Rhino? Okay, so there's a reason I'm here. So a lot of times, at least at Fentress, conceptual design happens in Rhino, but we do a lot of our programming in Revit, and we want to get that data over somehow. So what I'll show you today is how to use just out-of-the-box Dynamo nodes to transfer some geometric data into Excel, feed it into Grasshopper, and rebuild all those rooms three-dimensionally. And I'm going to do something crazy. I'm just going to build it from scratch and see what happens. It's totally not going to work.
No net, ladies and gentlemen.
No net. Okay. So I'll give you a little hint of what we're going to be working on here. There it is. This is a personal project I made a long time ago. It's my first project. First firm. Firm is called Shvartsman and Sons. Went under pretty quick. So we're going to go through a process. We're going to filter all of our unplaced rooms. We're going to filter any nonlinear boundaries just for the sake of the exercise today, so we can kind of simplify the whole thing. We're going to restructure our information, and we're going to send that data to Excel. And we're going to see if I can do this. Tobias will let me know if I'm running out of time.
Wow.
Okay, so we'll start a new document. First thing I want to do is collect all of our rooms. Revit selection. We haven't done that today, have we? Not funny. Elements category. Here we go. It's hard working on a slant. So this will access my categories. This will access all the elements in my category. I think I'm set to auto. 91 rooms in my first building I designed. And next thing I want to do is I want to get the area of this. So I'm going to type in room.area. Thank God that was the right one. And this will give me the area of each room, which is great. And oh yeah, I'm going to pull out a little node called not equals. Anybody heard of that one before? So I'm going to plug my area in here, and I want to find out if the area does not equal 0. And then I'm going to filter out my rooms. This is my favorite node, filter by bool mask. It is. It works every time. It never fails me. And I'll put my elements in here, and I get a separated list, not because this is the Revit sample model and all the rooms are placed, because Autodesk does a good job building its models. So I might group that. I'll call this nothing for now, because I don't have time. So next thing we do is filter out some of these your boundaries. So what I want to do is get the room boundary. In order to do that, I'm actually going to go over here to Revit Elements, go down to Room, and I think I'm going to grab the center boundary. And I'll plug that in, and we get some stuff. Right? I can't believe I designed this building. All right. It'll get old, I think, eventually. So next thing I want to do is I want to filter out something. I don't remember what it was. Oh, yeah. I want to filter out all the arcs. So if I look at my list here real quick, you see here, if I zoom in, I have lines and I have arcs. I don't want to deal with the arcs right now because it's another chunk of things that I have to do. So I'm going to turn all of this information into a string. And what that means is just a bunch of textual characters, and it says the same thing. But it's different, I promise. And I'm going to ask if this string contains something called arc. Okay, and I'll get a separated out list probably. And I will do a, oh, my favorite one, filter by bool mask. And I'll plug these true false values in here, and I will take this, and I should only get out, oh yes, a whole bunch of things. But I want to clean all this stuff, and I only want to clean it from the out list. Maybe I went a little too fast there. Everyone following me so far? Why that happened? Oh, good. So the next thing I want to do is I want to clean this list because I got a bunch of null values in here. So I asked if the name of this geometry has arc in it, and if it does or does not, it either goes in the in or out. If it does, it's an arc. If it's out, it's not an arc. It's a line, and that's really what I want. So before I do anything with this, I'm going to clean this list because there's a bunch of just crap in here. Null values. And it always asks me if I want to preserve the indices. And I never do. Right? Like I want to clean it. So I'm on an incline, so it moves. I did it. All right. So I clean my list. Real fancy. Okay. Now I want to do some other stuff. How am I in time, Tobias? Awesome.
5 minutes in.
What?
Yeah.
I feel like an eternity up here. All right. So I have only lines now, which is great. So I'm not getting, the reason we had arcs in here is because of these columns, right? They're kind of punching through the floor. So those are not a problem for me anymore. And I'm going to find the start point of every line. I'm going to type with my left hand and one-handed because my mouse keeps sliding down. Now I've got the start point of each one of those curves. Sorry, each one of those lines, right? So here you can see this is one room. Line, line, line. Four-sided room. I found the start point of each one. That gives me 4 points. I'm doing this because when I send this data over to Rhino and Grasshopper, I'm just going to use those 4 points and I'm going to redraw that loop. Nice and simple. So the next thing I want to do is flatten this list. It's really hard to type with the left hand. Okay, and that's great. Now I have all this point data, which is wonderful. Next thing I'm going to do is I'm going to break this down into X, Y, Z because I want to generate a table that looks kind of like this, where I have an X coordinate, Y, Z coordinate. I have a point count, which tells me how many points I have for each boundary. I have a room name, a room number, a room height, and an element ID. Why do I want this? Because I'm actually going to assign this data to all the stuff in Rhino. And so you might be asking, well, Ron, why don't you use mantis shrimp or bubblegum or whatever the hell else exists? Well, because a lot of them don't really attach that bit of information. And because Flux went out of business, and you know, I'm not sure what quantum is yet, but I'll find out soon. I hear very good things. So I'm going to get the X, Y, and Z. Bear with me. Point.x. .y. This podium is not optimized for.
Did it design to Autodesk?
I don't know. So I put this in here and I get the X, Y, and Z coordinates of my points, but I need some more information. I need the point count. So I'm going to use something called count. And that will give me, one from that list actually, right? Oh, this one. I don't know if we have time to explain levels right now, but why not? So here we have our levels. Level 1 of information, level 2 of information. I don't want the count at level 1, it's going to give me everything. I want the count at level 2 for each one of these lists at 0 and 1 and so on and so forth. So that'll give me a count of 4 and a count of 26, which we're getting over here, which is just fantastic. Now I want some other basic information like, sorry, bear with me, room name, got it. We want the room number. And, you know, it's actually, it's all right here. Let's just do that. Thanks, everybody. Name, number, height. And I also want the element ID. So, where are my rooms? I'm back over here. There they are. Let's just grab this and bring that over here real quick. Really hope this is the one I want. You know, when you're nervous and you're moving around with a bunch of hoses, you don't know what you're plugging into and what you're plugging out of. But I think it's pretty good. My phone's dying. This could be pretty bad. That's pretty good. I think I'm gonna make it. Let's put that on here. And next thing I want to do is I'm gonna start merging all this information together so that it forms into a spreadsheet. But before, I want to put a header at each one so I know what the hell I'm dealing with. I like code blocks. I work with a guy named Brian Mackey every day who hates code blocks. He says, how are people going to learn what you made if you use code blocks? Well, I feel like they're pretty intuitive. I think that was the point. So I'm going to make an X coordinate, Y coordinate, make a Z coordinate.
Keep going, it's recording.
Oh, it's recording.
Yeah.
X coordinate, Y coordinate, Z coordinate.
Might be.
Come on, guys.
That's gonna be awesome. You're gonna turn it back on, and it's gonna be done.
Or it's just going to break. So I'm basically just typing in all of these. This is a great time for it to break down because I'm just typing in a whole bunch of headers. Point count, room name, room number, room height, element ID. Cool. Okay, so what I'm doing now is all these little lists I made, X, Y, Z, count, room name, number, height, and element ID. I'm pulling out a little, but you guys can actually still see it, kind of. Anyway, I'm using a node called list.addItem to front, and I'm just taking all this information. I don't know if I'm doing it right. See, I did it wrong. That one's wrong. Boy, I hope that's right. X, Y, Z. That looks right. And I'm just taking each header, room name, and I'm adding it to the top of that list. All right, it's going to be my column of information. There's room number. So in case I'm in the other room is wondering what happened, Autodesk became self-aware and it retracted the overhead screen. Here. Sorry. I think I'm doing this one, room height, right? Put room height in here. And the last one we'll do, it's all ID. Now there's a faster way to do this, but I think that this kind of makes it clear, you know, working with lists, and we are adding some things to the top of that list. So if I look at this one, at the top I have element ID and all the element IDs of those rooms. So next thing I want to do is merge all of this useless information together. Maybe that's enough. And this will make a list of columns, which I will then transpose, which I think we talked about earlier, so that I can make rows of information. So there's the first column, x coordinate. Next one will be y, z, so on. And I'm going to do the old transpose. If I look at my information now, there's my first row. All the headers, right? And the last thing I want to do is write this to Excel. So, write. Which one is it? Which one? It's this one. There we go. And I need a file path. And I'm going to browse my desktop, apparently. It's my stuffs folder. Geom data. That's where I keep my stuffs. And I need a sheet name, which apparently in the Excel file I named room data. And that'll be my sheet name. Move this over a little bit here. I need a start row and a start column. And that's going to be 0. Right? And that's just the upper left-hand corner of the Excel document. I need my data, this overwrite thing. Cool. And I'll set that to true. No, I'm going to set that to false. No, I'm going to set that to true. Apparently my phone says to set it to false, but and let's put this over here. Let's put this down here. Let's put this up here. And let's, oh, it already ran because I'm in automatic. But let's come back to this in a little bit. Let's go to Rhino. And I have kind of a pre-made file here. And I have some buttons here. One is read Excel data and one is update geometry. So I have a Grasshopper script that is, I think, using 2 add-ins, one just to read an Excel document, the other to bake all the information into Rhino a very specific way. But I'm going to turn this off. I'm going to turn that on. And all it's doing is reading an open Excel document. Right? So I don't even need to save the file. It's just sending the data to Excel. And as long as it changed, it's kind of going to pick up on it. It's taking 20 seconds to compute today. Oh, look, it went fast. And I'm going to update geometry. Hit this button. Hey, there it is. And if I go to my layers, you can see each layer is a room with the room number. And if I go to my properties and I click on one of these guys, I have an element ID and again my layer name, right? So let's say I want to go back and make some changes because I think someone was talking earlier about messing with Revit models. I also like to mess with Revit models. I don't dimension, I just move walls. And then I sync. And then I go home.
Go on vacation.
Doesn't like that one. I'm not going to move that one. I go on vacation. Move. I really want you to see the change. So we're working at level 3. I'm just moving these walls because you'll be able to see the update. And move that. I'm going to move all these guys over. I've actually been moving these all night. I don't even know where they were to begin with. And I'll just move this last one. Okay. And it's been running the whole time. Son of a... Really hurts my feelers. Let's go down to the bottom. And I'm just gonna move one wall. I just want you to see the data moving. You know, I just want people to see it. Put this down here. I practiced this a couple days ago. I'm gonna run. Anyway, it updated. That's the point. And I'm gonna go to Rhino. I'm gonna go back to my little situation here. I'm gonna uncheck that. Check that. It's gonna think for a second. And what's nice is actually gonna remember every single thing. It's going to remember what's changed. So it's not actually going to rebake everything and copy it. It's actually understanding in a very hacky way how to bind all the elements. So if you look over in the Rhino space, oh, come on. Did anything move? My file path? You should get up here and finish this for me. That actually is great because now we can see the data move.
What a showman, Ron.
Thank you. I did it on purpose.
Yeah.
There we go. So our data updated. Fancy dandy. Yeah, if I come back to Rhino, I guess we'll try that again. See me hovering up here. Up here, I'm waiting for these buttons to bubble at me. I do this a lot. Hey, they're bubbling. They moved. So the idea here was that we have a lot of people, especially on a lot of airport projects we do, that do all their conceptual modeling in Rhino, and we do all of our programming in Revit because all of that data is there and it's rich. We want to use it. And this is a good way to get them to actually use a design process with their digital tools, which also doesn't sometimes happen. People are just kind of thrown out there, and one person's in SketchUp, another's in Rhino, another's in Revit, and another one's in 3D Max.
What does this grasshopper graph look like?
Oh, sure. How much time do we have?
That was your buzzer, but
This is the graph. So it a couple buttons up here, and I'm just live linking this to the Rhino doc so I can read the Excel data and update the geometry. This reads the Excel information. This does a lot of the similar stuff like cleaning it and sifting it out and transposing it. And then we build the geometry. And then we use this little guy to bake, and it remembers, it just remembers what it baked and what it didn't bake. And that's the deal.
Could you explain the workflow again?
Yes.
So going back and forth, or round tripping, or what?
I'm not round tripping. I'm going one way, Revit to Rhino. You could round trip. You could. The reason I show this is because there's a lot of broken design processes that I find at the office, and a lot of them are due to the fact that people are constantly importing and exporting files, and they're not, as a team, beginning at the very beginning, sitting down and saying, we need to design a design process that involves our digital tools. So one situation might be that they can send all this 3D data over, and someone can begin to model the enclosure or the roof around it. They can begin to chop up those rooms. We can take that enclosure and we can somehow send it back to Revit, and the person who's doing the planning or programming in Revit can begin to update all of their rooms and send that information back. So you could create a feedback loop.
dealing with this as you do, you prefer that people use conceptual mass and Revit. Repeat the question.
Yes. So the first question was, are we making a round trip? No, we're not. We're going from Rhino to Revit. Second question is, do I prefer that people do their conceptual massing in Revit? No, because if I try and tell a designer they have to work in a certain tool, they're going to crap their pants. I don't think that Rhino does what Rhino does, and Revit does what Revit does, and the conceptual mass can do what it can do. But in terms of complex geometry in Rhino, I think that it's hard to beat. That's not to say that the Dynamo can't do it or that Revit can handle it, but you gotta know what you're doing. And a lot of people just want to go in and they don't want to be accurate. They don't want to create reference planes. They just want to go in there and they want to do everything awfully, make it look pretty and don't completely inaccurate. And Rhino's a really great place to do that. And so is SketchUp. So will I use this in the future? Some people in the office use this. I'm just waiting for something else to come alive, and so we can transfer our data around a little bit more freely. Any other questions? Okay.
Ron Shvartsman, ladies and gentlemen.